Hello there and welcome to this CS Watch video 019, and we're going to be looking today at logic gates. So in today's video we're going to be looking at what logic gates are, how they are used, and also what truth tables are. Before we get underway and before we start looking at this in more detail, we need to remember that everything which is done on computers can be broken down to ones and zeros, binary. In these truth tables that you're seeing, 0 equates to false and 1 equates to 2. Now we're happy we've got that background knowledge, we can actually start looking at this AND gate and beginning to understand what it does and what it can be used for. So on the diagrams you're going to see in this video on the left hand side, they'll all have, the first two will have two inputs, A and B. On the right hand side of them there'll be what the result is of the inputs coming in and then the output. So we can see on this one with A and B coming in, we've got AB coming out. So the A and B get merged together is one way to think about it for something coming out. With an AND gate, it is looking for A and B to both be true, so the result can equal true. So we can see here that A and B, if they are both true, they're equating true. If we have A as 0 and B as 1, we've not got both of them. They're both not true, so that only equates to it being false, 0. So again, you can see that A1 true, B0 false. If we're looking at AB after the process of the AND gate, it would still be false. If we're looking at the OR gate, it's the same principle. We've got A and B coming out, and we've got AB on the right hand side. And we can see here that instead of it both having to be true, it's only looking for one of them. So we've got 0 or 0 is 0, 0 or 1 gives us 1. We've got if 1 or 0, we've got 1. What this is looking for is it's looking for only one of the values to be true. And if the value is true, 1, then the result of it will be 1 as well. We've also got the NOT gate, and this is a really nice easy one to get your head around. Whatever comes into it gets reversed. So if 0 is coming in, we get 1 on the other side. 1 coming in, we get 0 on the other side. You need to remember that computers can all be boiled down to different circuits, and this is an easy way of representing those circuits. Here we've got a nice little diagram. So we've got A, B and C as a primary inputs. We've got a NOT gate at the top, an AND gate at the bottom, and then we've got the OR gate in the middle. So if you've got A going into the NOT gate, for D, that would give us, if we've got a 1 coming in, that would give us a 0. If we've got B and C equal to both being equal to 1, that would result in E being 1. So at which point, if we've got D being 0 and E being 1, that would give us a result overall of Z being equal to 1, because we've got the 0 and the 1 going in. And if you think back to the previous slides, that then can help you out. Similarly though, if we've got a 1 as A, B is 0 and C is 1, well, A gets flipped round from 1 to 0, so we've got a 0 over there. We've got B and C, they're both not 1, so that's going to be E as a 0. So if we've got D coming in as a 0, E coming in as a 0, Z would of course be a 0, because if you've got two things which aren't going to be true, you can't equate to true overall. So here's an exam question for you. Here's a few. We've got another circuit diagram here. We've got a couple of AND gates, we've got a couple of NOT gates and an OR gate. And the questions we're looking at here, what's the final value if A, B, C and D are all equal to 1? And what is the final value if A and B were 0 and C and D were equal to 1? I'll let you click pause, have a look at this video. If you want to look back at the gates as well before you answer this, be my guest. And now let's have a look at some answers. I hope this video has been helpful for you. Feel free to leave any questions or comments below, and I'll see you in a future video. Goodbye.